Okay, so good morning. This is Mrs. Often, and I'm here to review functions. So there's some major things that you need to know about functions: definition, how to represent, and how to evaluate. So our definition for function: a function from set A to set B is a relation that assigns each element of A exactly one element of B. So set A, here shown as time, is the domain. And as you can see, each numeral from set A has been matched with a single numeral in set B. Set B is called the range. Now, not all of the numerals in set B have been matched with a numeral in set A. And there's no real pattern here. I just kind of randomly drew some arrows. But again, A are inputs, or the domain. B are outputs, or the range. So there's many different ways that we can represent a function. The first of these is a mapping representation, and this is just a matching up. You can draw little bubbles or boxes, and you can see that I have this function. The number 1 is matched with 4, the number 2 is matched with 5, and the number 3 is also matched with 5. This is a function. However, in this next set, 1 is matched with 4, 2 is matched with 4, then matched with 5, then matched with 6. This means it is not a function because this numeral 2 has been matched with more than one output value. We can also represent functions graphically. This graph represents a function. You'll notice that if I draw vertical lines, at any time I draw a vertical line, it touches the graph in one spot. This function, this looks like a parabola that's taking a nap, is not a function. And you can see here the y-axis is a vertical line, and it is crossing the function here and here. This is called the vertical line test. So this is not a function, but this graph is a function. More representations of functions. In tables, we have a domain list and a range list. Here in the domain, a whole bunch of numbers matches to numbers in the range. You'll notice that each domain value appears only once with a unique range value. In this case, the number 3 has been repeated in the domain. One time it matches to 1, and another time 3 matches to 2 in the range. This means it is not a function. So we can look at representations and determine if something is or is not a function. In this class, one of the most frequent ways we will deal with functions is with equations. And so I have a whole bunch of examples of function equations here. X squared plus y equals 7 is a function. Y equals 2, that's a horizontal line. It is a function. Y equals the absolute value of x plus 6 is a function. Y equals the square root of x plus 1 is a function. These are non-examples of functions. X squared plus y squared equals 6. X plus y to the 4th equals 7. The absolute value of y equals x minus 12. And the vertical line equation, x equals 6. So these are all not functions. Move my slide over here. Okay. And if we want to be able to evaluate, I'm just going to get my markers, which I forgot. If I want to evaluate a general function, here's my function. It is a quadratic function. F of x equals x squared plus 1. I'm going to evaluate it first for f of negative 2, and then b equals f of the quantity x plus 2. I always write the function first, just to make sure that I've copied it correctly. That's one of my big errors. So you can see I've copied it, and now I'm substituting this value wherever I see x. I'm going to evaluate negative 2 squared is 4 plus 1 equals 5. This tells me, if I were to graph this function, that the point negative 2, 5 is on the graph of the function. Over here, I'm evaluating using an algebraic expression. This is going to give me a new algebraic expression at the end. So again, I've substituted x plus 2 in place of x. I've done that in parentheses because I'm going to need to square this entire expression. Please remember that x plus 2 squared is equal to x plus 2 times x plus 2. So I'll get x squared plus 2x plus 2x plus 4 plus 1. And combining like terms, I'll get x squared plus 4x plus 5. This new expression is what I get when I evaluate a function using another function. Last year, we also discussed that this could be referred to as composition of functions. And this will be a very important concept for those of you taking calculus. So please be sure that you're able to do this second type of problem. Less frequently in this class, we will see piecewise functions to evaluate, but you may still see them on tests, so I encourage you to review how to evaluate these. Piecewise function, as you can see, has 2 or more rules, and our first rule, x squared plus 1, is applied when x is greater than or equal to 0. Our second rule, x squared minus 1, is applied when x is less than 0. And I'm asked in this problem to evaluate for f of negative 2. My first job is to decide which rule to follow. Well, my first rule, I'll say, just a quick test, is negative 2 greater than or equal to 0? No. So it's not going to be the first rule. I'll check the second rule. Is negative 2 less than 0? Yes, it is. So I'll use the second rule. Okay, so now I'm going to evaluate using that rule, x squared minus 1. And again, substitute negative 2 in place of x. Squaring, I get 4 minus 1 equals 3. So I've evaluated that piecewise function at f of negative 2. Again, our steps are to decide which rule to use and to evaluate using that rules. So that's what you need to know about representing and evaluating functions.